Well, good afternoon, everyone. Thank you for attending the Collector for ArcGIS Working with High Accuracy presentation. My name is Kevin. This is Morgan. And we're both on the Collector development team. We're both product engineers, so we want to share with you kind of how to set up and configure Collector to work with high accuracy receivers and some best practices for things to consider when configuring those devices. So we're going to go through an introduction, share with you some use cases on how Collector is currently being used, and then we're going to go into getting started on some considerations that you need to think about when starting a high accuracy solution, and what type of things you might need. Then we're going to go through the field data, the Collector setup process for how we're actually going to configure the settings in the app itself to leverage some of the things that you need to configure for that receiver. Then we're going to go through a field data collection process workflow. We're going to share some tools and resources to help this process. And then we're going to share with you the latest and greatest that's going to be incorporated in the new Aurora project, which, for those of you who aren't familiar, that's currently in beta. It's the Collector Aurora beta version right now that we're going to be showing you. Right now it's for iOS, which is what we're going to be showing you, which I can share more details about that when we get to that part. Then we're going to have some time for some Q&A at the end. All right, so I'm going to turn it over to Morgan to kind of get us started off.
All right, so before that, let me do a quick survey. So who has using the Collector for high-speed data collections? Wow. So who has used using no Collector, maybe the RPAD or some type of high-accuracy solution in place already? Okay. Thanks. So Collector for ArcGIS is a map-centric data collection applications, and then it has three key components. The first one is use web maps. So web map is you can capture all your information, geographic information model into those web map, and then it can be leveraged across multiple applications. So Collector is one of them, but it can also be reused for the story map, etc. And the second component is it works offline. We know a lot of our users, they might go to some remote area or even in the city, you can still find some blind spot. And then in those areas, working offline is a must for them. And the third piece is it supports a high-accuracy GPS. So when we say about support high-accuracy GPS, it doesn't only mean it can connect to those receivers. It also means we provide a complete solution for the users. And later on this presentation, you will learn more about it, how this solution kind of includes. It includes help you build confidence about the data you collected, and etc. And also, Collector for ArcGIS is support iOS, Android, and Windows 10 devices. So how Collector is being used right now? So it's three categories. The first is used for collecting and maintaining the asset data. I know a couple of our users, they might have the old CAD drawings. So when they move those CAD drawings into GIS system, they may not have good accuracy in the global scale. And then so they might recollect those asset data, and also they might use the relay table and do the inspection workflow. Actually, Kevin and I did some demo theater, like show you how to use the relay table for inspections. And second category is used for capturing observations. They're used by biologists to capture the animal activities or about the invasive plants activities or maybe water level on river, etc. And last category is good for performing field assessment. Every time when there's a disaster happens, and Collector, you will see Collector in the news, and then used for the Collector damage assessments. From high-accuracy perspective, Collector provides some unique benefits. First, it's easy to use. The traverse from the DX water districts, their field crew doesn't have like strong knowledge about those GPS, GIS, and Travis kind of joined our Collector high-accuracy beta early on, like maybe 2 years ago, and then he used it to collect the hydrants and then use the EOS receiver, and then you just give them the field workers maybe some checklists to work on, and then it's quite easy for them to, for those kind of small government, they can just use it and for the data collection. So it's easy to use. And second is efficiency with processing on the fly. So the story here is a city of Centennials. They work with a consulting firm called CH2M. So they use the triple catalyst receivers for do some pilot project about the public work asset collections. And what unique things about the catalyst receiver is a subscription-based receiver. So the initial cost of the hardware itself is just some $100. So, but most of the cost is about the services you are using. So you have a wide range of different accuracy level to choose, and like from centimeter level to meter level. And then the charge is based on the amount of time you use. So if you just use like a week and then you just charge 1 week, so it can give you a flexibility to control the project budgets. So it is kind of unique things. And the third one, it is about a project that rock the alphas. And so basically they would like to collect the rockfall locations to analyze the activity of the alphas. And so because they are the researchers, and the location of those rockfalls is quite important to validate their models. So they use the character because we provide the GPS metadata fields for individual the rockfall locations, and it will provide the level accuracy, p-dot, h-dot, etc. So help them to build a confidence about the data they collected. So before you get started for high-accuracy data collection, there are a couple of considerations, and let me go through those considerations. So first, you also ask yourself, what's your project accuracy requirements? Because this requirement will drive a lot of decisions for the following up, like what receiver you are going to use, what collection services are you going to use for the receivers, because the receiver prices, it varies a lot in terms of maybe $100, really cheap one, to really like a couple of some thousand, like $10,000, etc. And also the receiver only cannot provide the level of accuracy you have. You also need to consider what correction services you use for the receivers. And next is the data transformations. Because if you are doing maybe 1 meter level accuracy, maybe the data transformation may not be a big issue, maybe collector already handled for you. But if you like to move forward to do sub-meter or centimeter sub-level accuracy, the data transformation you will be topic need to be familiar with. And then the last is about the base map used for collections. The base map, the consideration about the base map is two things. One is that you will use base map as a reference, and what's the accuracy of your base maps is important. Maybe your base map is not that accurate, and then the location from GPS receiver is accurate, you may not see a match, but who is right? Maybe the base map is right, or the location from GPS is right. So the base map, another consideration about base map is the spatial reference of base map, because it will impact the data transformation of your choices. So let me go to the details about those considerations. One is the receivers. So you can see we work with a lot of partners, and their receiver varies a lot. And from like some Bell receiver, maybe some $100, it provide meter level accuracy, and maybe some like high-end receiver, like Trimble has some high-end receiver like R10, R2, etc. And then so it varies, the price vary a lot, and also the capabilities also vary a lot. Some of receiver they support the multiple constellations, which means the GPS, GNSS, Galileo, etc. If your project is in some difficult environments, like maybe some forestry, and you have a lot of tall building around, and maybe you need like additional consolidation to improve the yield of your results. So those kind of considerations will impact the choices of your receivers. As I mentioned, the receiver alone actually doesn't provide the level accuracy you need. You need to consider real-time differential correction used with a receiver. And usually when you get a receiver, it comes with they will use one free S-bus correction services. Those S-bus correction services is delivered by satellites. So they will usually they're used by default. And then the level of accuracy achieved by S-bus, it depends on receiver. Some receiver can get like 1 to 2 meters, and some receiver can get like 70 centimeters, etc. And so let's kind of, if you would like to go more to sub-foot or so centimeters, probably you will go to some vendors to get the BIS correction services, or maybe sometimes the DOT departments, they have some correction services for use as well. Maybe our country maybe have their own type of correction services, either commercial one or maybe managed by the governments. And the way to deliver those correction services, you have 3 ways. One is a kind of common way, is through the cellular networks. And then, because actually the character work offline. So we would like to get the centimeter level accuracy, and then it needs, if you use the cellular network connections, which means you still need some type of connection. So you make sure you would like to get the level of accuracy, and then the correction services choices, the connection will be a factor to consider. So you might need to consider some correction services delivered by satellites, because there's some correction services, commercial one, they can deliver by satellite and can provide a different level of accuracy. And also there's another connection is through a radio, like traditional surveyor, they still use a radio to deliver the correction services. And to configure receiver to use those correction services, usually you will use some third-party app to configure it. And those apps usually is a vendor specific. And when you use those differentiation corrections, actually the consideration is when you apply those correction services, the GPS location is not based on WJ84 anymore. It will based on wherever correction services you are using. So when you get those correction services from vendors or governments, probably they will, in their website, they might put what datum they are using. And this, you should get those information because you are going to use those information to configure the datum's transformations. So since I talked about datum transformation, so basically the datum is a model of the physical world. So when you transform a location from one model to the other, and then datum transformation need to be set. And so that's why you see a location from GPS receiver to the web map, and the model may be different, so datum transformation will be coming into play. From a web map to each individual feature layer, they can have different spatial reference. So another datum transformation will come into play. And if you are using like SDE and then your service is using server feature services, then the TT3 step will be considered as well. In the TT1 step, it's defined in the location profile, which is configured in character level. And for TT2 and TT3, actually configured in a back-end systems. So what later on Kevin is going to show you is show the location profile is only deal with the TT1 steps. So you still need to consider how do you deal with TT2 steps. So let me talk about for TT2 step. So because when I support the customers, a lot of them will ask, what spatial reference should I choose for my web layer before my publishing? And ideally, I would suggest you set a non-datum transformation, which means it will be good that what basement you are going to use, you just set the web layer to be the same as the basement you are using. Because a non-datum transformation will minimize the minimize the accuracy lost. And then but you would like to set the web layer into some other spatial reference, then I'm going to show you how to do it. and in a demo. Actually, before I show you the demo, I just would like to kind of show you one PDF. Is in the our map documentations under map projections. Underneath, there's a documentation talking about geography transformations, and the one I'm opening. There are important factors to consider. The reason why I emphasize the data transformation it is when you look at data transformations, it has the accuracy of the individual transformation methods. So that's why if you choose the wrong one, even you get a centimeter level accuracy, the end result may not be the centimeter level. So that's why I emphasize data transformations. And also another factor is the area of use. Because each area, they will use a different model to model it, so transform it. You will need to consider the area use of data transformations. So when we come back to the demo, I'm going to show you about how can you configure the TT2 step. So when you publish the web layer into ArcGIS Online or ArcGIS server in the properties, there's one coordinate system, and this one will define what special reference of your web layer publish. And the web layer I have, this one, the test polygon, this layer is used, the data is a 93/211 state plane. So if I would like to set it, have a non-data transformation cases, then in these cases, it was set it as a WJ84 1 Mercator. But another thing to important is look at the transformations. In these transformations, and if you like to set the web layer into 93/211 state plane, and then when you look at here, that it gives you a data transformation between W84 to 93. And these choices here, when you publish it, actually the services will remember these settings. And so through this, you will configure how feature services will transform from the web map to the feature layer. So this is kind of give you an idea of how you control the TT2 step. Let me come back to the slides. And then now Kevin is going to show you how do you set up the characters like location profile, etc.
Okay, let me switch over to my iPad here. Okay, so what we need to do first is when a lot of the settings that I'm going to show you are operating system agnostic. You want to it's the same overall process and considerations that you need to make when you set up the data. In this case, I'm using a Bluetooth receiver. This is just an EOS Aero that I'm pairing to this, to my iPad. It's already been Bluetooth paired. As you can see, I'm connected. That's the first step you need to do outside of the app, before you go and configure the settings to use, this receiver. So inside Collector, I'm already in my app settings. And there's a lot of different settings that you can configure inside Collector for field data collection processes, but what we're going to be considering for this section is the location part right in the middle. There's a lot of important things that we need to do there. The first thing is we need to go into the provider section. Now, because I'm using an external receiver because I'm using an iPad and the integrated isn't accurate enough, the integrated is a built-in, I'm going to be switching over to this external receiver. However, this does, if you're using, let's just say Android, and you're using like an all-in-one device, you may want to continue to use the built-in integrated receiver because that has a better chipset than, say, an iPad does. So in this case, we're just showing you how to set it up to an external receiver. So right now, we're going to hit the plus sign, and I'm going to add my receiver because the Bluetooth pairing feeds that list. There would be nothing there if you didn't first Bluetooth pair it to your device. If you're considering vertical capturing elevations, this is where you would enter in your antenna height. If you're using like a range pole or using a tripod or anything of those type of setups, that's where you would put in that value. For this one, we're going to go ahead and skip it. Now that I've added it, I'm going to go ahead and select it, and that's pretty much it. So as far as setting up my provider, so that way I can go back and we can move on to our next area to configure. So right now we're going to go into our location profile like Morgan was talking about. The default profile uses WGS 1984. So that basically is saying that if you use default and you don't configure a correction service, it's making the assumption that your corrections are on the WGS 84, AWGS 84 datum. It's not going to be on, if it's NAT 83-2011 that you're actually using, it's going to bring it in as WGS 84. So that's where the importance comes in on setting this up. So we're going to go ahead and set this up. Now, the base station that we normally use, we have a base station on Esri's campus, and it uses GCS NAT 83-2011. So that's going to be the correction service that I'm going to use. But you may be having a correction service that might be in WGS 84. There's a few that I know of that broadcast WGS 84 base corrections. You might be using a satellite-based correction service that uses maybe a different datum. So that's where Morgan said you need to know what datum you're going to be using with your correction service to fill out this step. So this is the coordinate system of your receiver. So you can search based on the well-known ID, or you can just type in some text and we filter the list for you to make it finding it easier because there's a ton of them in there. So now we're on to the step 2, which is the coordinate system of your web map. So the base map you use defines the coordinate system of your web map. So if you're using ArcGIS Online base maps, they're all WGS 84 Web Mercator, but you may be caching your own base map services where you would be using that datum in here. So in this case, I'm going to go over to projected, and I know what the well-known ID is for Web Mercator, so I'm just going to type that guy right in, and then we're going to go ahead and choose that. Now this is where, in that PDF document that Morgan was showing you, where you have to take the area of use and accuracy into consideration, because I'm going between two different datums. I'm not using a null transformation, so I have to set where I'm at. So it can basically, what this does is when I get over to the next step, you'll see that I provide you a list of available transformations, and it's ordered by accuracy based on your area. So if you choose the incorrect area or you choose too large of an area, then you're going to get more options. But the one that's at the top, which I'll show you, will be the more accurate option to choose. Now you don't need to go right to the ground level. This isn't going to render your features in this display. This is just going to show you kind of just a rough overall area where you're at to help kind of refine that list. Okay, so if you were setting up a null transformation between two datums, this step would be irrelevant and you would skip right over it because you wouldn't need to set a transformation. But I'm going to go and hit next, and the one that's at the top is the most accurate one available that I have to choose from for these datums, so I'm going to go ahead and select that one as my option. And I'm going to give it a meaningful name because even though most of you probably are going to be using one type of receiver, one correction service so you're going to have one type of profile you're going to be configuring. You may be having scenarios where you switch to different types of correction services or you switch to different receivers. So you may have a scenario where you have multiple. So we're going to save this, and they're going to list it just the same kind of experience as you got when we did the providers, and we're going to go ahead and set this one up. You can also click on this little info button if you've set it up way back when and you don't remember what datums you chose. You can see that right here, and you don't need to reconfigure it if you've already built it. So that step, that's done. So we're good there. So now we need to look at the accuracy right here. Now this is the required accuracy value, which basically just filters out any locations that don't satisfy this accuracy requirement. This is very important, as I'll get to in a few slides after this demo, on some data collection that Morgan and I had done where we didn't set this setting accurate enough and it threw us off. So we set it low, but not low enough, and it messed with our fixed types. So basically, this will support feet or inches or meters and centimeters, depending on how you want it. It's important to know how to set this, because if you set it too low, then you're not going to be able to collect anything. If you set it too high, then you're running the risk of going outside of your range, or your accuracy may drop. If you have like an RTK fixed solution, you drop down to differential GPS, and you're not going to get notified about that. This is how you can control that. So if you want to say, I know I'm going to be able to get at least 10 centimeters, I don't want it to fall back any more than that, that's going to be your threshold. And then we have this 95% confidence setting. For those of you who need different methods of reporting your accuracy, right now we default to RMS accuracy, which has a 68% confidence interval, which is kind of an industry standard. But some of you may have requirements to say, I need to report at a 95% confidence interval. Basically what we do here is you turn it on and we apply a factor to the accuracy values you see, so that in the display, which we'll get to when I get to my demo, in the field demo, that you'll see that those values are reported higher, but at a higher confidence interval. So you have more confidence that that's the accuracy that your receiver is actually getting for the locations you're capturing. So if you don't need that requirement, then you can just leave it off. It's off by default. So I'm going to kind of go ahead and just set this down to 10 just for my scenario. So as far as setting up for high accuracy, again, there's a lot of other collect settings that you probably would be interested in for actually using collector in the field. But as far as just setting it up for high accuracy, that's it. And we're going to leverage some of those other settings when we get to the demo. So that's pretty much it. And these are per user settings, just like any settings that you configure inside collector. So if you hand off the tablet to somebody else and they sign in with their username and account, they're going to have to configure the same settings. So that's how how it's working right now. So let's go back over to the slides and we'll kind of move on. So we went over the location provider. It's built right into the collector where you configure your provider that you're using, provided that you've paired it in the case of an external Bluetooth receiver. But you may have, like I said before, you may be using the integrated receiver. So in that case, that step you wouldn't need to use because you're just going to use what the tablet already provides you. We do have Bluetooth receiver support. We do have support for serial receivers on Windows. And specifically for if you're using, and for Android, we have support for Trimble Catalyst. So that unit plugs right into the Android device in that case, but then for Windows, you could use serial-based receivers as well. So there's different types of configurations that we support. So this is where you connect to the named receiver and specify your antenna height if elevations are something you're capturing. So we have, when working with the receivers, if you're working with iOS specifically, iOS is a little more strict about the type of receivers it can support because they have to be iOS certified, which has to go through like a whitelisting process with Apple and with the manufacturer. Conversely, we have a whitelisting process that we have to do with that receiver as well, so that we all can recognize the connection. Mostly it's for Bluetooth pairing purposes, so we can recognize the receivers. So not every receiver is going to be running on iOS. Most of them do. A lot of the different ones that we work with and that you're familiar with, if you're already using it, are supported. Like, for example, like the Leica GG04 Plus, this was one that we just recently added that is supported for iOS. We have Bad Elf support, Trimble, EOS, all those ones that support for iOS. Windows and Android usually aren't a problem. Those are the ones that usually all of them will work with Windows and Android. So with location profile, again, very important step. Again, if you're using different datums, it's really just about if you're making that transformation between those multiple datums. This is where you configure between your receiver datum, and again, well, actually I should say your correction service datum, because all receivers provide locations in WGS84. So it's not the receiver that you're looking at, it's the service you're looking at. And then your map coordinate system. And for the datum transformation selection, in the current version, the current release version of Collector, we do not support grid-based transformations. That will change with Aurora, which we'll get to down the road. Which we'll get to in the presentation, down the road in the presentation. It's in there now. And then so you also want to provide a memorable name for your profile, in case you have multiple. So here's kind of an example of some data collection around Esri's campus that Morgan and I were kind of messing around with, just to kind of show you the impact of what a transformation offset looks like if you didn't set a transformation and should have been using one. It's kind of obvious, but you may not when you're looking at the data, because everything will be shifted consistently to one direction or the other. So the polygon to the southeast is the one that did not have the location profile set. The one that's kind of over the curved area is the correct one. So you can see that it's off, obviously. If you're in a situation where you're trying to determine if it's an offset due to transformation or if it's an offset due to just my accuracy, that's one way to tell. Everything, if it's not consistently shifted, but everything is shifted, then that's just that you have accuracy issues. Not necessarily that it's a datum shifting problem. But still worth investigating because it could be a mix of of two. So then we went into location accuracy, where I said this is where you set your required accuracy so you can determine how to filter out those unwanted locations. So if you're in an area where you're getting bad connectivity or you drop fixed types, this is how you can kind of throttle that a little bit. And then also where you set the 95% confidence interval. We're going to get into the next slide where, again, same collection that Morgan and I were doing around our campus. And you can see kind of the importance. So if you look at the image on the left, Morgan and I were doing a streaming in this scenario. I had originally set my required accuracy to 10 inches We were getting 0.3 inches with this receiver, so we were getting very good accuracy, but we weren't paying attention, and it dropped, and you can see that we were starting to kind of deter a little bit from the curved area. So when we noticed that, we had to stop, wait for the RTK fix, because we went to an RTK float solution, so we dropped from 0.3 to 7 inches, and then that's when we noticed that we were off. So once I waited, it snapped back to my fixed type, and then I was able to continue on, and I fixed my required accuracy to be more relevant to what I was actually getting. So had I had that set lower, then I wouldn't have been able to continue walking on and not know that my accuracy had dropped. So something to kind of just be aware of. So it's one of those settings that's not really like a one size fits all. It's kind of like you just have to know the area you're collecting and kind of fill out how to set it up if you're the one actually collecting the data in the field. So now we're going to kind of go through the field data collection process. And what we had done, because obviously we can't demo it indoors, so we're going to kind of run a video and kind of walk through this actual same data collection where we're going to kind of see it in action. And it's using the same settings that I went through with you before. It's the same profile and all that, so I'm not going to go through setting all that up again in the video, but at least you're going to see me using it. So let's get that running. All right, so first of all, again, we're using the EOS receiver for this data collection. It's the same steps if you're using Trimble, if you're using Bad Elf. You need to configure using the third-party app. This is the EOS Tools app that we're using for this case, where we're configuring the connection, an N-trip connection to our base station through a cellular connection. We're going to start the streaming to get that RTK fix solution. Again, it's the same if you're using Trimble, if you're using Bad Elf, if you're using Leica, similar workflows where you have to go through their app to set up that service. So now we got fixed. You can see we got 0.005, very good on my HRMS. So now we're going to go back into collector. We're just going to quickly take a look at the settings, make sure that they're good. I will drop down that accuracy a little later. So the same one I just showed you, RTK between AD83 and WGS84. So I just want to double check, make sure it's still good. And then we're going to go back to the field. Okay, so it's going, I promise. Okay, let's go back there. We'll get into my map. So for the scenario that we're performing now, it's kind of just like landscape maintenance, kind of walking around, collecting some areas around our campus, some tree locations. So just lines and polygons, or sorry, points and polygons. So this is our campus up in Redlands, and we're kind of in the northern part of our parking lot. So we kind of have this cool shape that we're going to walk around. But this is the badge, the GPS badge that's on the map, and it's a pop-up. It's expandable. So you can see that it's absolutely necessary for you to know what the receiver is doing. If we didn't have that, you wouldn't know what accuracy you're getting. That badge will actually turn red if you're outside of your required accuracy value. So you'll know visually that you're not getting any locations. So we've started our collection. We've already streamed that. We kind of saved you us walking around a polygon. So we're just capturing some tree locations at this point. We got the location. We got 0.9, I think 0.9 accuracy. We're just going to fill out some attributes here. Now we're down. We've got 1 inch. So it kind of fluctuates. And yes, it was at 8 p.m. at night. All right, so we're going to kind of keep walking around. We're submitting those updates. And then we're going to walk to a different location. What we're showing here is the metadata. So we have 18 fields worth of metadata that we capture from the fields, 14 of which are for what we refer to as single shot locations, which is what I just did. We have 4 fields dedicated for averaging. And when you average, it's important to know that certain fields become irrelevant and we turn them off, such as PDOP and HDOP. They're not applied to averaging. We don't capture those. We don't average PDOP values. So we will show that when I go to averaging right now. So we do have averaging. I'm going to set this up for 20 locations. Averaging is very useful if you're in a location like, say, tree coverage. You want to try, and you're right at that location, and you want to try and average out some of the errors that you're getting from your measurements. It's important to know that averaging does not increase accuracy. It just helps increase precision. So if you're already at the wrong location, averaging is going to get you to the right location. It's just useful in certain applications to help average out errors if you can't get a good shot from a single location. So we're going to hit that. You can see in the upper left corner, we're counting our locations. So we're going to see, and you're going to see actually, if I was zoomed in a little bit more, that that red dot is actually going to move around, and you'll see that that's the averaged location. We've improved this experience in Aurora, the new version, where you actually will see the point cloud render on the field. We don't keep the point cloud after we are done averaging, but it's really clear to see if you have an obvious outlier here. So that experience has been improved a little bit. So same tree, same that we're populating, and then we're going to throw in an attachment. You can see, yes, we are at night, but we do have good lights, so we're good. So it's not too bad. We're going to submit this, and then we're going to take a look at that metadata again. So you'll see that certain fields that were on before are now off, so that you can see that certain fields don't apply anymore. So horizontal accuracy and vertical accuracy, PDOP, HDOP, VDOP. So now horizontal accuracy and vertical accuracy are now in an averaged field. We also have what's called a standard deviation field. That's a numerical value to kind of give you a numerical representation of the cluster of your points. So you know if it's really high value, you probably want to capture that again. So now what we're going to do is I'm showing you that we support what's called overzoom, base map overzoom. So basically, if you have a cached base map that goes to a certain tile level, we're going to let you zoom beyond that. Because if you're stopped at, say, 1 to 1,000 or whatever the case may be, and you have really tightly clustered points, they're going to show up as one dot, and you're not going to be able to see them accurately. So we let you continue to zoom past that level to where you can see them, and like in my case, you want to measure the distance in between those features. You can do that with the overzooming behavior. Okay, so now what we're going to do is we're going to go back and we're going to play around. Just I want to show you what that 95%. So you can see we have like 0.2, 0.3 inches right now. We're going to go back and we're going to turn on that 95% confidence interval, and you're going to see that value get increased. So we're going to show you that. Come on.
Is it allowing you to turning off?
Yeah. It's going. There's just a pause here. Okay, let's go back. Let's open it up, and now you can see that our accuracy is now increased, almost double. That's because of the factor that we apply, and it's a standard factor that we applied based on the conversion factor between RMS and 95% confidence interval. So that would be how you would want, and you can see in the badge, I just showed you that it did say 95% HRMS. So that's how you can tell visually that it's displayed as 95% confidence interval. Okay, now we're going to go back to the slides. Okay. So just to kind of give a good recap, we talked about the GPS badge. It's absolutely essential for any type of GPS field data collection. You want to know what accuracy you're getting, what fixed type you're at, how many satellites you're getting, and then it also shows you your correction profile. That's one way to know, one good check before you go out into the field to say, open up that badge, make sure correction profile doesn't say default, make sure it says something else. That way you know that you're using what you've set up. Because you may have set it up but forgot to select it, and that's something that can happen as well. Base map overzoom, great for going in beyond the sample, the scale range. You can see that clustered point a little spread out. And we have support for metadata fields. We have, again, 18 metadata fields worth of data, 14 of which are unique for averaging. Great as if you want to keep that audit trail months down the road, you want to find out what accuracy your point was collected at. So great to have that information. And averaging, you can set up averaging. Averaging is one of those things where the more points you choose, the more accurate, the more precise you're going to get. It just depends on how long you want to sit on each point. Okay, and then Morgan's going to go over some tools and resources that are helpful.
As Kevin showed the importance of have GPS metadata fields, so we'd like to make it life easier for you to add those fields into your existing feature layer of data. So there's a couple of options. The first option is the host feature layer. So in ArcGIS Online, ArcGIS Enterprise, you have host feature layer. So when you create a host feature layer, there's a checkbox underneath. When you turn this on, the checkbox captures GPS receiver information. When you turn it on, when you publish these feature services, you will automatically add those fields and configure the pop-up for you. And also in ArcGIS Pro 2.2, actually I have Pro 2.2 here. Under the data management tools and the fields, you can see we have this new script adding in the system tools, add GPS metadata field. You can use this one to add your existing geodatabases before you're publishing. So this is kind of convenient way to add those metadata fields into the existing geodatabases. And if you don't have the Pro 2.2 yet, and then when you look at our documentation, we have one section talking about record GPS metadata fields. And then these sections, we show you what the metadata field we support for single shot, or GPS averagings, and then etc. And also tell you some other scripts help you to do that. And then we open one of script here. Actually, I already opened here. So we have in a public GitHub page, we have character utility tools, and yes, a couple of scripts available, and then some scripts for the add GNSS metadata fields, and then the other script like the analysis of project Z tools. Maybe I will talk about this later.
These are also supported in toolboxes, so you don't have to run them as Python scripts. If you're not comfortable with Python, you can download the repo and add the boxes, toolbox into Pro. Most of those scripts are supported in Pro. A few of them are supported in ArcMap, but we have separate toolboxes for each of them, so you don't have to run it as a script if you're not comfortable with that.
So another tool is useful is called a Project Z, Geoprocessing Tool, if you are interested in the Z value. And then so basically in current character classic, we don't support the Z value as geometry. So we see people will use a Project Z tool to convert it into geometry. Actually, they do even more. So they would like to leverage the ArcGIS Pro vertical transformation capabilities to convert we call it HAE height into isometric height. And what the use for isometric height is determining how the water flow. So that you can tell the water flow direction based on isometric heights. So it's really, this tool is useful for the water utility customers. When they collect the assets, they will use these tools. And other use cases if people will use for collect the ground control point for the drone use. So the screenshot here actually is Yucaipa water district. We have like 18 control points using by characters. So let's switch gear to character Aurora. As I mentioned, the Z value is not supporting existing market version of character, but in Aurora we support a Z value. But currently in current beta we don't have vertical transformation, but we plan to support in the near future. This is kind of in our roadmap. Another thing we add into the Aurora is grid-based transformation support. When we work with customers from the UK or customer from the Canada, some of them they require like grid-based transformations to get the level of accuracy they need. And then we support two ways to deploy those grid files. One way is you can download directly from ArcGIS Online. So basically is when you configure the location profile, and then on the data transformation list, if they want grid-based transformation, we have cloud buttons for you to download it. Another option is you can silo those grid files into the iPad. And another useful capability is the campus mode. So like some surveyor or some people when they do call a stake out, and then the campus mode is quite useful to help you to navigate the existing assets. Kevin is going to demo using the Auroras.
So in the demo, we're going to use the same kind of setup that I showed you before in the last one. It's the same receiver, same map that we were using before. But in this case, we're going to kind of be using Aurora, and we're going to be going through not only just some of the things we showed, we'll be going over the compass mode, how that works. We're going to show kind of also just the user interface and how it looks. And also we're going to show like different ways you can orient the iPad, like we do support landscape and portrait. So we'll go over that. Okay, so again, same setup as we did before. we're going to go ahead and just start the streaming, the RTK streaming in this case, and then we'll switch back over to Aurora and go over a little bit more. Okay. Okay, switching over there. This is my required accuracy value. So it's before, so that's the same. Again, everything we talked about before applies to the new version that we're going to be releasing shortly for iOS. So this is just kind of what's different about the two. So we're going to do averaging. Boom, we're done. We just did kind of a streaming for this location. So we've got the streaming done, and then we want to just collect a few tree assets. So you can see right away that the user interface is different. We don't have that badge in the bottom left corner like I showed you before. That's now called a GPS banner. See where it says in black text at the top? It's a GPS accuracy. If you tap that, that is expandable. That's our new quote-unquote badge. It's now a banner. So it's slightly different, but all the pieces are still there. So we walk down to this tree. We're going to collect a location. That's our new location target. So that will be centered at my GPS location. But what's really nice about it, on a side note while I'm collecting this, is that because it's a location target with crosshairs, it's easy to manually place a point if you want to move it, so you don't have to try and guess how you're going to tap. So it's really helpful for manual. Okay. Well, we kind of skipped ahead, but that's okay. So we just collected a few points. You didn't miss anything in between that skipping. But you saw that I can rotate the iPad, and you can rotate it to support portrait mode. So what's really nice about portrait mode is that you have a lot of attributes. You get more real estate, especially on this iPad Pro 13-inch right here. So it's really it's really better on an iPad to be able to support the different orientations of the device. So we're just going to submit that. We get a different kind of submit. So we refer to this as our sliding panel. When you can, because you can, in the phone, it's the same experience. So it's not just iPad, iPhone, same thing. It's a similar experience. But the thing is, if you're familiar, I didn't demo the phone here. Well, we had it at the island. Hope you guys had a chance to go down to the island. And if you talked to us, we had a version down there. But while this is being filled out, actually you can see here I support the same metadata fields that we did before, so any existing maps that you're working with are just going to work right in Aurora, so it's not like you have to do anything to change those maps. It's directly ported over. So I'm walking over to another tree, and we're going to just kind of do a similar process. Now we're going to look at compass mode. Compass mode is very cool. I'm going to select an existing asset, and I'm going to have it route me over to where it's at. So I'm going to select my tree in a second. It's going to be, so on our campus, that little black area, that's a flood channel. So I got to walk around that. So you'll see kind of how I go. So I'm going to go down to the bottom. I'm going to say compass. And then it's going to take me there. I got to so there I go. I reorient myself. And on that banner, you can see I got a bearing now. So it says south about 220 feet. So as I walk, and it will change, you can see that it will, with the accuracy level that I'm getting, this feature will allow me to get right on top of that feature. Actually, when I get there, you'll see that I chose a feature that was kind of in a gated area, so it wasn't the best one that I chose, but I got next to it, so I know what feature I need to choose. But if you were doing something like a hydrant that you can get right on top of, you'll see that will get right on top of it. And especially if you're looking for features that are really close next to each other, and you want to know exactly which one is which, if you're at 0.4 inches, you should be able to find that clearly. So as I walk, you can see that my direction will change, my bearing will go, and I'm going to kind of speed that up just a little bit because I think you guys are kind of getting the point. So I kind of want to show you as I get closer. Obviously, I'm the furthest point away at this point. So we'll see, I'm going southeast, now I'm going east, and it tells me where to go. It's a really helpful feature. I don't have to just route to existing features. If you have a location you want to go to and you want to drop a pin on the map, you can compass to that location as well. You don't have to compass to an existing asset. So it's really helpful, and you can get to that location, and then you can, like in my case, I'm going to start doing some editing, but it's just another tree, so it's not going to be anything different than I showed you at this point. So that's basically compass mode. It's very helpful when paired with a high accuracy receiver. I can't get any closer than this, unfortunately, because I didn't pick the best point apparently, but it's the same idea. If I was able to, I'd get right on top of it. So now we're going to go ahead, and this is just me editing that feature. So that's about that. You already saw that.
There are some section I think already happened before actually. So there's some recording about coordinate system, data transformation. You can kind of find online, maybe on YouTube, and then you can understand more about the data transformation. And
so before we get into the Q&A, I think a lot of you are kind of curious if you've not heard of Aurora before, if you want to know more about what that is. Let me kind of maybe headline some of those questions. So Collector Aurora is our new ground-up redesign of Collector. It's not going to be called Aurora, it's going to be called Collector. It's just under the beta project name Aurora. And it's not going to be a direct replacement. In other words, it's not going to be an upgrade to the current version of Collector. It's a completely different app. Right now, we're currently in beta with iOS, plan to go release soon this quarter. And if you're not in the beta program, we highly encourage you to be in the beta program by emailing collectorbeta@esri.com. That way we can get you signed up. The beta for Android will be hopefully within this quarter as well. So it will be soon. And then Windows will follow. So when they go, what we're going to do is we encourage you when you're on iOS, we do encourage you when it goes release to move over to Aurora, but both apps will be in the store for a period of time. No further development is planned for iOS when Aurora goes release, but you will have them both parallel, so you can kind of use them both while you train the field crew on the new one. So it's not going to be like a direct update, now everybody's got to go to the new one. So, but we do want you to kind of be familiar with Aurora, start using it, get in the beta program. There's a lot of great stuff. We only showed you the high accuracy stuff. If any of you were in our other presentations this morning about authoring maps and the great things that we've added for supporting sync, auto sync, multiple areas per map, there's a lot of cool stuff that Aurora can do. So we encourage you to get in there. So, but now your questions. So hopefully that helped if you had any Aurora questions. Yes? The offset collection?
So offset collection, when you talk about offset, are you talking about No, just talking very distance offset. That's a good question. We do have, right now, we're looking primarily at what is support in server collector highlighted last week. But you're also looking at also you can drop.
Yep. I'll get your contact information. Okay. Any other questions? I'm sorry, who asked that? Oh, laser rangefinders. That was a similar, similar question. But Doug, would you answer that? Similar to that one?
So for laser rangefinders, we just released a version here with EOS and laser technology.
Not sure how to answer those.
To have solution on the current version collector with iOS. So if you're using an arrow receiver and a true pulse context, you want to use that with collect to either range offsets or backside offsets or a standard offset.
Okay.
That's supported now. We will be adding support for laser rangefinder offsets later after we finish our initial release of Aurora. So that is something on our development roadmap.
Yes.
How is the Project Z tool doing? How far along is it, and what's the eventual outcome of that?
So the Project Z tool is provided in those scripts that Morgan showed you. So it's not a tool that's built into the platform. It's kind of our workaround, basically, solution for the fact that we don't have direct support for vertical transformations. That's what we're waiting on. So hopefully by the time those get released, that tool will not be necessary for those occasions. But essentially what that tool does is it is more or less a modified version of just the normal project tool. Basically how we do it is the metadata fields that we capture, there's an altitude field that we capture metadata for. We capture the ellipsoid height in that altitude value, in that field. So you don't even have to have a Z-enabled layer. That value will still be captured in the metadata. And then what happens is when you run the tool, essentially we output a new copy of that tool, that layer. So you take your original data, you run it through the tool in Pro or ArcMap, and it will output a new copy of that Z-enabled, where we inject those altitude values into the Z after you also apply a vertical transformation. So if you're in Pro or ArcMap, you need to have the vertical transforms installed, which is a separate install from the desktop app. So
eventually the vertical transformations capability, all those kind of geotic model will be built into Aurora collector itself. That will be the ideal world. So I guess that's what people will need, because right now the Project Z tool, what you can do it's good for you collect new features. But if you like to revisit the locations and those kind of things, it cannot be done through Project Z tool. But that's the requirement for some of our users. They would like to navigate it and then compare maybe the pipeline locations, the elevations, compare with the current location, and when they do the layout of pipeline, make sure the water can flow in right directions. So eventually we will need to include like this vertical transformation, those geotic model into the collector. And actually, ideally, we will need to also push for, as I show you, the data transformation happens in multiple pipelines, from the receiver to web map to feature layer. So ideally, will be push the other teams to support either both in collector side or feature layer side. And we have a whole story of the vertical data, G value collections. So there will be timeline. So maybe next year. That will be things we'll push for you. Maybe you can get your content and then get your use cases. Maybe you can help us to drive the development of other teams as well. Actually, that part is majority work won't be in collector side. It will be other teams side. So we need maybe get more use cases for it, and then we can push forward about this.
Yes. Yes, that's on our roadmap. Yes, correct. We do plan that. Oh, sorry. Good thing. He was asking about snapping, about point snapping or line snapping. If we're going to be planning to support that, and yes, we do plan to support that. Yes, that is on our roadmap. So cool. When? Doug, do you have a question on maybe have an idea? Thanks, Doug. Any more questions? All right.
All right. Thank you for attending.
Thank you for attending. Enjoy the party if you're going. Thank you.